first thing to do in this question is to draw a diagram. So here's one that I did earlier. And of course, it's going to be quite hard to do anything this accurate on paper just by hand. But as long as you're trying to show that basically start at a single point A, and then the pentagon is going to go, I almost want to say want to go around faster, but the angles are um, going to be smaller. So it's kind of like P is quite close to B, but then it gets further and further away until actually you need an extra side for them to meet again at A. I'm going to talk about two ways now to calculate BAP, which is this little angle here. Okay, method one, if you can draw accurately, then it's okay to see that there's a line of symmetry going down the middle. I put A right at the top here. And what that means is I can work out um, the interior angle of a hexagon, which is 120, and then halve it to give 60, because this is what it'll be on the right-hand side. And then the interior angle for a pentagon is 108. Divide that by 2 to give 54. So that one is 60. This one is 54, which means the green angle is going to, which is the one we're interested in, is going to be 60 minus 54, which is 6. Okay, when I drew the diagram, it didn't quite look like it was, symmetrical, but you've got to sort of try and visualize and understand that it will be. Let's talk about an alternative way of doing this problem. In fact, I think I'm going to come up with a new diagram. Right, again, I want BAP, this one here. Okay, this time I'm going to use the center of the circle to help. So I can draw a line from the center that goes to A and then goes to B. And I can also draw an, actually, let me deal with this first. So this is for the hexagon. Now I've split it into a triangle and I could draw equivalent triangles going to the other points. They'd all have the same angle at the top. Basically it'd be 360 divided by 6. So this is going to be 60, and therefore this angle here is also going to be 60 because I have an equilateral triangle. It's just the fact that it's isosceles is the most important thing there. So that angle is 60. So if I can work out this red angle, I'm using a slightly different approach, then I'm again sorted. So let me draw another triangle. I'll make it purple. So I'll go from the center, just one sec, to here. Right, now this angle at the center is going to be 360 divided by 5, so it's 72, meaning there's 108 left to share with the isosceles triangle that we have, which becomes 54. So this angle is 54. But more importantly, this angle is 54. So I've got exactly the same result as I got the first time round, but in a different way. I can again subtract them to give our answer of 6. Nice.